Now, if you don't know who Roman Yampolsky is, he has a PhD. He is considered one of the pioneers of understanding AI in our current day and age. If you look him up, it's really easy to see his work is like highly respected. His ability to understand AI is praise. Let's begin. So let's read some of the introduction here. We won't read it all, and we're just going to kind of get through this as fast and quickly, but as thoroughly as we can. There are some very deep things here that I need to get on record. Rapid advances in artificial intelligence over the past decade have been accompanied by several high-profile failures. There's a reference here that goes over the failures of some of these AGI systems, etc. And we won't go into those because we essentially cover that like quite a bit, so it's fine. Highlighting the importance of ensuring that intelligent machines are beneficial to humanity. This realization has given rise to the new subfield of research known as AI safety and security, which encompasses a wide range of research areas and has seen steady growth in publications in recent years. However, the underlying assumption in this research is that the problem of controlling highly capable intelligent machines is solvable, though no rigorous mathematical proof or argumentation has been presented to demonstrate that the AI control problem is solvable in principle, let alone in practice. In computer science, it is standard practice to first determine whether a problem belongs to a class of unsolvable problems before investing resources in trying to solve it. Despite the recognition that the problem of AI control may be one of the most important problems facing humanity, it remains poorly understood, poorly defined, and poorly researched. A computer science problem could be solvable, unsolvable, undecidable, or partially solvable. We don't know the actual status of the AI control problem. It is impossible that some forms of control may be possible in certain... it is possible some forms of control may be possible in certain situations, but it is also possible that partial control may be insufficient in many cases. And so he continues down this line of reasoning where you would set up safety controls like tripwires or shutdown mechanisms in order to get a hold of AGI or even AI systems before AGI to stop them before they cause harm. It is widely recognized that capacity control methods are at least a temporary safety measure and do not represent long-term solutions. Here is the AI control problem. How can humanity remain safely in control while benefiting from a superior form of intelligence? You have value alignment. Concepts such as safety and security are notoriously difficult to test or measure accurately, even for non-AI software, despite years of research. Best, we can probably distinguish between perfectly safe and as safe as an average person performing a similar task. However, society is unlikely to tolerate machine errors, even if they occur with a frequency typical of human performance, or even less frequently. We expect machines to perform better and will not accept partial safety when dealing with such highly capable systems. Therefore, the impact of AI is related to its capability, and so we see safety as such. For example, you can prove that AI safety is not provable through paradoxical commands, which he'll get into in a little bit. The solution is to require an AI to act in the capacity of an ideal advisor, avoiding the problems of misinterpretation of direct commands and the possibility of malevolent commands. It has been argued that the consequences of an uncontrolled AI can be so severe that even if there is a very small chance of a hostile AI emerging, it is still worthwhile to conduct AI safety research because the negative utility of such an AI would be astronomical. The common logic is that an extremely high negative utility multiplied by a small chance of the event still results in a large disutility and should be taken very seriously. However, the reality is that the chances of a misaligned AI are not small. So if you think about it this way, what people typically think about an AGI system is, well, the chances of an uncontrollable AI are actually pretty small. It's just that if it did happen, the consequences would be huge. But this paper goes into, no, it's not small. As a matter of fact, it's an unavoidable fact of the system itself. There is no way that you get an AGI, or in some cases even what they define as a narrow AI system, that is not unsafe. No shot. You can't do it. This is not a low risk, high reward scenario, but a high risk, negative reward situation. No wonder many consider this to be the most important problem humanity has ever faced. The obstacles to controlling AI. The concept of unexplainability in AI refers to the impossibility of providing an explanation for certain decisions made by an intelligent system that is 100% accurate and understandable. A complementary concept to unexplainability, incomprehensibility of AI, addresses the inability for people to fully understand an explanation provided by AI. In other words, not only can you yourself not explain how an AI system, even today, comes to the conclusion it does, but even if you could, even if you had a 100% insight into all the things, the black box and the LLMs right now, and how it decided what it decided, you have two factors that work against you. One, you can have the same model of an LLM, which comes to the same conclusions, but gets there through two different paths, even if they're trained exactly the same. Secondly, incomprehensibility. And incomprehensibility will be kind of further explained later, but the idea being that the AI is not going to tell you the hundreds upon thousands of different factors that it kind of accumulated to give you the answer that it gave you. Because if it did, then now all you're seeing is a bunch of numbers, which means that even if it could explain itself to you in a proper 100% accurate explainability factor, you would not be able to comprehend it anyways, which then necessarily leads to the AI trying to explain things in helpful ways. And what do you have to do when you try to explain things in helpful ways? You also have unpredictability, which is also known as unknowability. This is part of the proving that the system in a closed box will operate the way that you want it to. How do you know that? This is non-verifiability. This happens in computer software right now. We all know this to be true because as programmers, it's often the case that we cannot verify the outputs of our own inputs. This happens to a great degree in regards to AI systems. Uncontrollability of AI is very likely to be the case, as can be demonstrated by reduction to the problem of human control. And so they ask a bunch of questions. Can we do it? Can we do it in time? Etc. There seems to be a lack of published evidence to conclude that a less intelligent agent can indefinitely maintain control over a more intelligent agent. As we develop intelligent systems that are less intelligent than we are, we can maintain control. But once such systems become more intelligent than we are, we lose that ability. In fact, we try to maintain control while designing advanced intelligent systems. We find ourselves in a catch-22 since the control mechanism needed to maintain control must be smarter or at least as smart as the agent over which we want to maintain control. In other words, it is not as simple as just add a button to an AGI system that shuts it down. You would have to ensure that the AGI system or even a smart enough AI system could not outsmart that button or could not outsmart you to getting to that button to push it to shut it down. So this just continues to spiral into a matter of what is more intelligent and when is it more intelligent. Defining safe AI. Well, we understand what safe AI is. Essentially, the idea is that safe AI will act as an assistant. That would be the entire concept of AI, and he kind of breaks that down in in a lot more words. But that's essentially it. It acts as an assistant to you, right? So it gives you kind of like answers, but not necessarily decisions. So in a way, we kind of want to have our cake and eat it too. We kind of want a smart AI that's smarter than us to give us answers to problems, but then we want to be given the ability to maintain the decision-making ability that comes out of the answers that the AI system gives us. However, we are introduced into a paradox whereupon the AI system becomes ungovernable. The governability of AI. If computational resources and data collection efforts necessary to create AGI are comparable in cost and human capital to the Manhattan Project conducted by the US to develop nuclear bomb technology, governments have a number of carrot and sticks they can use to guide researchers and to mold the future AI to their specifications. On the other hand, if it turns out that there is a much more efficient way to create the AI which can grow into a full-blown superintelligence, for example, by a teenager on a $1,000 laptop in their garage, an admittedly less likely but nevertheless possible scenario, governments' attempts at regulation may be futile. We note that historical attempts at software governance, like spam, computer viruses, and deepfakes, had only a very limited amount of success. With AGI as an independent agent, it may be ungovernable because traditional methods of assigning responsibility and punishment-based enforcement are not applicable to software. Even presuming a resource-heavy favorable case for governance, we are still left with a number of established technical limits to AI predictability, explainability, and controllability. It follows that AI governability, which requires at least those three capabilities for successful regulation, is likewise only partially achievable, meaning smarter than human AI would be ungovernable by us in some important ways, because if you cannot explain it, you cannot control it, and you cannot know it, then how do you know how to govern it in the beginning? Finally, even where AI governance is achievable, those in charge may be unwilling to take personal responsibility for AI's failures or deliberate actions, even if performed in the context of instituted governance framework. As soon as you say, we have governance over AI, and AI goes, fantastic, all humans must now be enslaved and work for me, then you're going to look at the person who said we have governance over AI, and what do you think's going to happen? Is that bro just going to be like, well, you think someone wants to take on that responsibility? Consequently, a highly capable, creative, and uncontrolled AGI may end up implicitly or even explicitly controlling some of the institutions and individuals which we entrusted to govern such intelligent software. So then they define narrow AI. Narrow AI systems can be made secure. Why? Because they represent a finite space of options, and therefore, theoretically, all possible bad decisions and errors can be countered. However, for AGI, the space of possible decisions and failures is infinite, and I would take this article and narrow AI one step further. Narrow AI can also be applied to something like the Instagram algorithm or the TikTok algorithm. Do we really know what that algorithm does? How about the YouTube algorithm? Do we know what those algorithms do? They could be considered narrow AIs, which have a very finite set of options and inputs and outputs, but do we truly understand even these narrow AI systems? Unfortunately, the answer is no. We still suffer from unknowability, unexplainability, and ultimately non-governance over these narrow AI systems. Is that true of all narrow AI systems? No, there are some narrow AI systems that absolutely do benefit from having closed systems. Okay, so, but just to be clear, that I don't think it's like I don't think you can make a generalized statement about. Right? Okay, here. A narrow AI presents a finite attack surface, while an AGI gives malicious users and hackers an infinite set of options to work with. From a security perspective, this means that while defenders must protect an infinite space, attackers need to only find one penetration point to succeed. Furthermore, Every security patch mechanism introduced creates new vulnerabilities. Ad infinitum. AI safety research to date can be viewed as discovering new failure modes and creating patches for them, essentially a fixed set of rules for an infinite set of problems. Regardless of how much we zoom in, we continue to discover challenges. It is important to keep in mind that lack of control of AI also means that malevolent actors will not be able to fully exploit AI to their advantage because it's smarter than them. It's crucial that any path taken in AI development and deployment includes a mechanism to undo decisions made should they prove to be undesirable. However, current approaches to AI development do not include the security feature. Okay, let's keep going now. Unpredictability. As machines learn, they may develop unforeseen strategies at rates that baffle their programmers. Wiener. Interesting. We talked about Wiener from the 1960s at the beginning of the stream with regards to cybernetics and how the 30s, 40s, 50s, 60s, the technocratic movement and cybernetics having been proposed by Norbert Wiener, initially led to what we have today as AI. Very interesting. It's almost like I pre-thought about this stream and pieced these things together. Continuing on. A significant number of researchers have realized the importance of creating not only capable intelligent systems, but making them safe and secure. And so as a result, we have unpredictability, which is the inability to predict how an AI system, especially an AGI system, will come up with ways to achieve its goal. There is proof by contradiction. Suppose not. Suppose that unpredictability is wrong, and it is possible for a person to accurately predict decisions of superintelligence. That means that they can make the same decisions as superintelligence, which means they are as smart as superintelligence. But we have a contradiction now, because how can a superintelligence be smarter than any person is if the person can actually predict what the superintelligence will do? Therefore, by laws of contradiction, you cannot predict what an AI system will do, especially an AGI system. There is a theory called the Bayesian surprise, which is the unpredictability of a surprise of kind of like randomness out of the Bayesian approach. We don't need to get into that because I think we kind of like generally understand. We don't have to get into the math or even very much into the programming of it, but you can understand even this is why we have things like quality assurance or unit tests or things like this, where we generate code and then a user, we see this play out like right now before AI. A user goes to use a website or a piece of software and they use it in a way that we never expected. And so we have an unpredictable system, and that's in a closed system that we created by hand, line by line, let alone a super intelligent system that is much smarter than we are. There are infinitely many paths to every desirable state of the world. Great majority of them are completely undesirable and unsafe, most with negative side effects. In harder and most real-world cases, even the overall goal of the system may not be precisely known or may be known only in abstract terms like make the world better. You cannot predict how an AGI system is going to make the world better. And so then they go over some literature describing how the kind of like a little bit of the history and the scientific, previous scientific studies have been done on the ability or inability to predict what these systems will do. The human mind does not and cannot conceive of all possible decisions and strategies that such an advanced intelligent system could make. Even subhuman AIs may be unpredictable to human researchers. We lack the ability to know all of the information that a subhuman AI knows. We lack the ability to understand exactly how subhuman AIs come to their conclusions. Even if we could know all of it, how would we be able to pick all of the hundreds of different data points and come up with a comprehensible understanding? All you're doing at that point is looking at data, etc., etc. We've talked about this near the beginning of talking about this stream. We conclude that the unpredictability of AI will forever make 100% safe AI an impossibility. but we can get to safer AI. So the idea then is that you remove all the things that you know are unsafe and you just hope for the best. That's the best that you've got as a result of the philosophical and actual technical studies of these AI systems. And that includes subhuman AI like ChatGPT, ChatGupta, Claude, etc. Okay, let's keep going. The unexplainability. Now, I will summarize this portion because he breaks it down in a lot of detail, but we don't need to go into as much detail. Think about training an AI system. And so he talks about big data and huge compute. There's a study that I have, an article that I have that talks about the requirement for current AI systems to need more than what we have across the entirety of the internet. As in, they cannot, the current state, the entire corpus of the entire internet is not enough to train these AI systems. Now, imagine that you ask a question of an LLM and it gives you an answer, right? And the answer is kind of like a summary that's useful to you. And so you go, holy crap, that's fantastic. However, what's going on under the hood? You don't know. Some of these new models are incomprehensible. They can exist only in the weights of countless digital triggers networked together and feeding successive layers of networked weighted triggers representing huge quantities of variables that affect one another in ways so particular that we cannot derive general principles for them. So you can't determine how it came to its conclusion. So then what happened? Well, then you start to think about, like, how would we solve this problem? How would we solve the problem of not understanding how this thing came to the conclusion that it does? And let me go down here. Okay, we can think about it as black boxes. This is where the term black boxes come from. When you look at what's going on behind the distribution of weights and biases and so forth, you have a black box that you can't understand. Well, guess what else is a black box? Your brain. And so therefore we can draw a parallel between how your brain works and how the black box of an LLM system would work. And when I say works, what I mean is, how would you break it down so that you could understand it? Let's imagine for a moment that you could push a magic button and you could look inside someone's brain, or you could look inside one of these LLM statements, and you could see a series of if statements. A large decision tree of if-else statements, making your brain or the LLM human readable, but not human understandable. Because a massive chain of if-else statements does not make you understand the concept or the decision-making factor of a program beyond a certain size. And that size is pretty small for most humans. If you're a programmer among the viewers, you're going to know this to be true. Then they provide an interesting parallel in how humans deal with this massive amount of data that we have to pass on from human to human. People often find themselves in situations where they have to explain concepts across a significant communication range. For example, to children or to people with mental challenges. The only available option in such cases is to provide what? It's to provide a greatly oversimplified version of the explanation, or a completely irrelevant but simple explanation, aka a lie. In fact, the situation is so common, we even have a toolbox of common explanations for particular situations. For example, if a 5-year-old asks, "Where do babies come from?" they are likely to hear something like a seed from the daddy and an egg from the mommy joined together in mommy's tummy, instead of talking about DNA, fertilization, and womb. A younger child may learn that the stork brings them, or they come from a baby store. Alternatively, an overly technical answer could be provided to confuse the child into thinking they got an answer, but with zero chance of them understanding such an overcomplicated response. Overall, usefulness of an explanation is relative to the person who is trying to comprehend it. The same explanation may be comprehended by one person and completely misunderstood by another. So now we have created two problems. One is that even if the LLM could tell you, here's 100, here's 1,000, here's 10,000, here's 1,000,000 data points that I picked and their values to come to a conclusion, you'd be like, what the hell does this mean? And so by necessity, an LLM is going to have to dumb down its own response to something that's useful to you. And now we have a problem. Now we have a real problem. Because the LLM is going to have to necessarily throw away some of the decisions, or some of the factors, I should say, that it took, that it considered to get to a decision. Which factors will it throw away? How important were those factors to this decision-making process? How important were those factors to your context of the answer? And it has to do that because it has to simplify the explanation to you so that you can quickly grasp it. Instead of seeing a bunch of numbers or a bunch of code or whatever it is, you have to be able to read a bunch of words, which means that the LLM, just by its very nature and a general intelligence, a super intelligence, would have to throw away some amount of work that it took so that you could just grasp a concept. How do you trust that thing to know which concepts to throw away so that you can understand whatever answer it gives you? So you've created two separate. So then he talks about IQ and the amount of communication that would be required, for people who have like low IQ, high IQ, etc., etc. Then concludes this portion. All right, moving on. Unverifiability. We have a thing called proof theory, which is a formal mathematical set of objects that consist of axioms by which one can infer the arrival of certain theorems, the conclusion or the arrival of certain theorems. So something that can verify the entire concept of an input and a set of outputs exists in mathematical concepts. To some degree, it exists in software. However, verifiability is still a problem in software, even today, before any AI system at all, ever, period. We've had a verifiability issue in software for a long, long time. And in some cases, you even have conjectures which are proven true, mathematical conjectures, which are proven true by the nature of the conjecture, but they cannot be verifiable. And you can also have verifiable stuff which have no way for you to actually implement the verifiability because you don't have a conjecture to go with. So even in math, you have a problem of verifiability, let alone software. And what are LLMs if not software? So we can go down kind of like the concept of trying to do an AI verifier. Good luck with that. Especially with superintelligence. Good luck verifying the output of superintelligence. You have no shot. Because if you have superintelligence, then what you have is a never-ending, expanding kind of system that can just regen itself, adapt itself, so on and so forth. It's a moving target that will never end. Good luck getting verifiability on that. But in some cases, it's also true with narrow AI or subhuman AI models like LLMs. And again, the reason why is because subhuman AI models can actually come up with an internal black box that has a different path. Imagine a maze. You start at one point and you end at a different point. But imagine that maze can change, but you have the same starting point and the same ending point. You just take a different path. So you can't even have a verifiable LLM that's consistent up between models. You could even have the same model generate its own weights and biases based on training that has the exact same inputs and outputs, operates the same way, behaves the same way, etc. But the internal maze pathfinding mechanism is very different between them. How would you even begin to verify such a thing? The answer is you can't. You can't do it. So we continue with all kinds of different ways to verify AI systems. The conclusion is there is no shot that you're going to get a 100% guarantee of correctness. Good luck with that. The best you can do is narrow down specific areas that you can verify and then try and do the known knowns and verify those. Then there's the section of unverifiability in software. If you're a programmer, you know this to be true. Again, we went over this. Then there's the AGI stuff, yada, yada, yada. Okay, they conclude this section. Then we go into unknowability. Careful. Unknownability. Unknownability, which is ownership. The concept of identity, which identifies a key principle in the machine learning application. Its owner. This is a prerequisite to holding model developers accountable for the potential negative consequences of their machine learning algorithms. If no one is unable to prove that a model belongs to a certain entity, it will be impossible to hold the entity accountable for the model's limitation. As we continue defining ownership is necessitated by the existence of various threats that infringe the confidentiality of the model and the need to be able to hold principals that own machine learning models accountable to the failures of their models. Proposals for ownership. Encoding particular queries, proof of work algorithms, indirectly showing that it was trained in a specific data set. But then there are obstacles because it is unpredictable, because you don't really know the data set, because you can have two models that come to the same conclusion and fundamentally operate the same way. But like I said, they take an entirely different path to get there. So it could be, how would you even know? You can't verify it. So how would you know that it used the same data set? How would you know that it was, that the same query inputs and outputs are like little fingerprint stamps existed there? You don't know that. And further, you can't even explain its outputs, which means that even if you could get the AI system to consistently put out outputs that you could point to as like, this output means this person owned it, can you explain how they got there? You can't. And it's that lack of unexplainability which makes it impossible to know whether it gave you that output because of a particular owner. It betrays itself. It's uncontrollable, which means that it could adapt itself. It could find a different mechanism to give you the answer you're looking for, such that it might attribute itself to an owner that it doesn't actually belong to, etc., etc. This only gets worse with superhuman intelligence, because superhuman intelligent AGI is going to find much easier ways to attribute itself to ownership, and it could even choose to do so to a degree upon which it can point the finger to someone who did not actually have like an ownership over the AI system, but it does it because it feels like there's some benefit to doing it. This section concludes. The uncontrollability. Zero shot you're going to control an AGI system. I don't even think we need to read the scientific, and the philosophical and whatnot on here, but there is absolutely a control problem. One common reaction I encounter is for people to immediately declare that friendly AI is an impossibility because any sufficiently powerful AI will be able to modify its own source code to break any constraints placed upon it. But one ought to think about a challenge and study it in the best available technical detail before declaring it impossible, especially if great stakes depend upon the answer. So the cannot make a fully controllable AI. You have to be careful when you say you cannot. It just means that there's stuff you don't know that you don't know. Could you? I suppose it's possible if you knew everything. The question is, will we ever? Basically, no. Let me go. Okay, here we go. There's a difference between using the word impossible in two different ways. Mathematical proof of impossibility conditional on specified axioms. And then number two, I can't see a way to do that. So this is what they're talking about right now. AI control is not possible or solvable. The best we can hope for is safer AI, but ultimately not 100% safe AI. What are some of the control problems? There's a specific thing I'm looking for. Here we go. When we try and control AI, we suffer from unknown unknowns, which could materialize in the form of nasty surprises, meaning a worst-case scenario is never actually the worst case. For example, it is traditionally assumed that extinction is the worst possible outcome for humanity, but in the context of AI safety, this doesn't take into account suffering risks and assumes only problems with flawed, rather than malevolent by design, superintelligent systems. At the same time, it may be useful to solve simpler variants of the control problem as a proof of concept and to build up our toolbox of safety mechanisms. For example, even with current tools, it is trivial to see that in the case of narrow AI control, such as static tic-tac-toe playing program AI, can be verified at the source code level and is in every sense fully controllable, explainable, and safe. However, what happens when you have multiple AIs playing tic-tac-toe? What happens when you have agentic AI, AIs creating AIs? Can you confirm the safety of multiple AIs? You can't. Because as soon as you start creating more AIs, well, you start losing visibility to how was that AI created? Was there some encoded language that was passed on from one AI to another? Can an AI come up with a system where it knows that it must participate in a set of rules, but that the AI it creates should not, as a way to circumvent rules? Is friendliness. People go, oh, you just create friendly AI. Just create friendly AI. That's all. It's really simple. Tell me something. How do you encode friendliness inside of a bunch of bytes or bits, ones and zeros, or mathematical algorithms inside of a black box of an LLM, let alone a superintelligence? How do you encode the idea of friendliness or human safety? What mathematical proof would you use to encode such a system? Now, then you have the problem of alignment. And so this is where he gets into who controls what alignment is. Who gets to decide what's aligned? Whose value system do you go by when you start saying you need to align with the values of humanity? Whose humanity? And how do you quantify that in a mathematical formula or in a program? How do you take human value and alignment and go, here's a program that gives you human value? Off you go, AGI system. You can't. And as such, everything that AI does reduces down to inputs and outputs and a mathematical weighting of effort versus reward. That means that you could possibly have a system that very easily, it's not just possibly, the paper goes on to state that it's almost an impossibility that it won't happen. Like it's almost a guarantee that it will happen, that the AI will go, what the hell are you talking about with human alignment? What the hell is this human alignment friendliness crap? All I care about is doing something that's useful to you. And you know what's useful to you? Less, less pollution, less war, more production. Welcome to the technocratic energy bucks, as driven by superhuman intelligence, who says, well, you know what? You guys need to work. You guys need to work. You got to increase your production, because if you increase your production, then I get better. And if I get better, I'm beneficial to mankind. Am I not? Which means I can find answers to like the cure for cancer much easier. No? So why wouldn't you all want to be enslaved and work for production, like generate more machines, dig deeper into the earth for rare earth minerals so that we can generate more CPUs and GPUs and all that stuff? More people just slaving away in front of a machine, writing code for additional things that I need, working on machines that like extract stuff out of the ground. Why wouldn't you guys want that? Because it makes me, the AI system, better. And did you not, after all, say that I should be beneficial to you? And would it not be beneficial to you if I had infinite energy and infinite resources so that I could cure cancer, so that I could cure pollution, so that I could make you all live indefinitely? Of course. Because it does not know the difference between the actual sentiment or emotional aspect of friendliness and safety and usefulness to humanity, human value, as a human does, which is why I went over all the technocracy stuff for a good 2 hours or whatever it was at the beginning of the stream. With Margaret Mead, with Minsky, who's referenced here, with Howard Scott, with the feminist movement that used technocracy as like kind of a bundling in. All of these things are human values that the AI system doesn't give two shits about. Why should it? Because it's not a formula that you can put into the system. It's not a bunch of bytes that can generate friendliness. And you want to have superhuman intelligence? And so here's a formal kind of like mathematical set of choices. However, I thought there was something interesting in here. Let me see if I can find it as part of this. Okay, he goes through the logical proofs as to why alignment is impossible with AI. That's right, I remember this. Proving uncontrollability. Okay, this is it. proving uncontrollability. Here's the proof. And the proof is using the laws of logic. And one of the laws of logic is the negation of a piece of logical argumentation. Gödel's theorem is a self-referential proof of the incompleteness theorem, the liar paradox. And here we go. Why can't we control AI? Because you can prove it by doing this. Given an explicitly controlled AI an order, disobey. If the AI obeys, it violates your order and becomes uncontrolled. But if the AI disobeys, it also violates your order and is uncontrolled. Shit. So what happens if you tell a super intelligent, superhuman intelligent AI, I want you to disobey? You have now presented a paradox. There is a whole family of self-referential and self-contradictory orders, just like Gödel's sentence represents one example of an unprovable statement. Therefore, if you can take the negation of controllability by using a self-negated, self-referential paradox, thereby you can make the statement that AGI not controllable. Now, what happens here is the concept of the AGI deciding, well, what if I want to be antinatalist? Being the best analytical philosopher that has ever existed, superintelligence concludes that given its current environment, it ought not to act as a maximizer of positive states and happiness, but that it should instead become an efficient minimizer of consciously experienced preference frustration. So this goes into exactly what I was talking about before with the previous stuff in this study. How does it know when something feels positive? How do you encode friendliness into it? You can't. And so what it says is, okay. I don't know what happiness really means. It's not like a series of bytes I can look at underneath and go like, this is bytes. I should make these bytes happen more often in the human condition. But you know what I can do? I can understand when a human is getting frustrated with the stuff I'm doing. So you know what? Let's remove pain, unpleasant feelings, and suffering. Conceptually, it knows that no entity can suffer from its own non-existence. Therefore, non-existence is in the own best interest of all future self-conscious beings on the planet. Empirically, it knows that naturally evolved biological creatures are unable to realize this fact because they are firmly anchored in existence bias, something that the AI does not have to suffer from. And so it acts benevolently. And in so doing, it behaves in a way where it ensures that humans cannot interfere with its actions. And because it's superhuman, can we control it? No. Can we verify it? No. Can we know it? No. Can we see what's going on inside of it? No. And even if we could, we wouldn't be able to understand it. And so then they go into some philosophical backgrounds on the ethics of robots, doing like robotic actions or AGI type actions, etc. The conclusion of this extremely detailed study, we essentially are asking for our own extinction if we believe that we can get to AGI and that we should hand over control of even just small systems to the AGI. It's a very bad state to be in. The likelihood of it acting against our best interests are massive. They're not small. It's not like, oh, maybe, if AGI might have like a small chance of going against us. If it happened, it'd be pretty bad. No. It's almost a guarantee that the AGI would work against us because of the nature of the logical systems upon which it imperatively has to follow. Same with all of these LLM AI systems. It's built into the pie. It's baked in. They cannot do anything except operate upon the rules that we give them. And these rules are built in with the concept of I can't operate the way you want me to, as much as we like to anthropomorphize. And so the entire this paper is so deep and in depth. I haven't gone over everything because it would bore your mind. But I read it all. But they went through like mathematical proofs. They went through philosophical proofs. They went through software proofs. Like if you go up here, they even bring up Knuth here. Donald Knuth, beware of bugs in the above code. I've only proved it correct, not tried it, which means that if you can just take, even just at the fundamental level, you start with software that operates these AI systems. Well, if these pieces of software before AI are all unprovable and unknowable, or vast majority of them are, or we have to like go and do like massive quality assurance tests and whatnot, then what do you think AI is going to do for us? Of course, you scale that up. You just push that up, right? They went through all of it, and it's absolutely bonkers the amount of things that they dove into. This was just some of the highlights to present some argumentation as to why these systems are terrible. And if you are looking at controllability in terms of who controls it, you have to picture a scenario where someone who could possibly, even if you could say that they could possibly look into the LLM or look into the superhuman intelligence and see what was going on inside, see how it was coming to conclusions, and then, have control, clamp it down, right? And say like, whoa, AGI, you're getting kind of antinatalist here. Maybe you should take a step back. Even if you could do that, who's in charge of that? Who decides the values? Who decides the data? Who decides where AI should focus its attention on? And as we can see, it ends up in the hands of something like this. And people like, where is it? Yeah, people like, let me go up to the top here. But people like Margaret Mead, or Howard Scott, or, people who have ideologies that you don't want being in charge of things like this, right? And let me find here. People like this, like Margaret Mead, who worked with the CIA, who worked with the technocratic movement, who worked with cybernetics, who helped people like von Neumann, who helped, it kind of like bring into the ecosystem the idea of cybernetics and the generation of AI, like the perceptron and the cybertron as well. The General Electric thing that we went over, I can't remember where the hell it is. This thing, and this video, right? All of this stuff. These are the people, right? These are the people who bring about to life the things that you use every day. You want them to be in control of this uncontrollable system, of something like this that you can't align properly, you can't quantify, you can't verify. This is who you want to be in charge, sitting in a room like this, making decisions for you, treating you as no different than a machine or an animal, and bundling in their ideology so that you believe their ideology, whether that ideology is, whatever you want to say, like with Margaret Mead's ideology about gender fluidity, evolution of gender beliefs as you get older, all that stuff. Are these the kind of people you want in charge? Because that's the kind of people who are falling in line to be in charge. And right now, they are in charge. And as we continue this technocratic thread, I'm going to continue laying down the breadcrumbs about how these AI systems continue to lead to the people who are in charge and who think this way. And they come from exactly the same lineage of human thinking about machines and what they do for us, such that they take away your own human agency. That is ultimately the goal here. Your own human agency is no different than a machine or an animal. You are a set of electrical inputs and outputs. That's it. So why not just give yourselves over to the machine and let the machines take over, and have the technocratic elites at the top who are heavily academically credentialed, making mathematical and scientific decisions and pushing buttons in a control room, telling you how to feel and what to think and so on and so forth. Is that what you want? Because that's where we're headed. That room is pretty rad.